And I thought that if I enabled them once, it would stay on, but apparently not. But they're on now. Is that true?
Yes.
Okay, good. I just need some more paper towels. What a great invention, paper towels. I mean, what did they do before paper towels? Like reuse their towels? Wow, that's crazy. All right. So how about we begin with review? What would you like to talk about? Questions? Questions, everybody? From the book, from the course, questions about your projects? Oh, that's dry enough. Nobody has anything to say?
No,
Maybe
I don't have a question.
could you maybe briefly go over the format command? I forgot exactly what the different parts of it work like.
Okay. First, let's find it in the book so that you'll know where to go if you have questions after I do my best to answer. So let's go here. And let me change this over here. Okay, so chapter 7.2. Okay, Asher. So if the questions that, the answers that I give right now aren't satisfactory, you might get some more insight from this chapter. And of course, there are other sources of Python information, but this chapter is pretty good. Floating point precision, the width. And let's see, do we have, good, we have alignment, so left and right. Good, all right. And what about the different types? Oh, look at that. We haven't talked about fill characters, so that's what's on screen right now. Fill characters. We haven't talked about that. Why don't we, yeah, why don't we use that as some examples? All right. Okay, so I'll go to Replit now. And this is where I can get to Replit from here. Okay. Okay, so the general structure of formatting looks like this. Exactly like that, right? Yeah, there you go. Okay, so there's some type of template string, and then a period, and then format, and then arguments. So what goes in here? That's your template. So it can either be straight text. So if you said hello, then hello would be printed. Or it could be an introductory brace and an ending brace. And then what goes inside of the braces is formatting instructions for handling one argument. Okay, so some of the, let's continue. Now, inside the braces, there's a colon, and there are certain things that can come before the colon and certain things that can come after the colon. So let's talk about after the colon. We've learned about using a width specification, and that's just a number. So let's say 10. So that means whatever's going to be printed is going to be a minimum of 10 characters. So if it were a number that could be expressed with one digit, it's one digit in a field of a total of 10. Other things that can go there is alignment. And the alignment characters are left aligned, right aligned, centered. Okay. There's also a precision, which is only for floats. I should get my letters out in the right order. So working in conjunction with width, so let's say it was 10.3, the decimal place. So this is 3 digits after the decimal place in a total of 10 places. Let's see, what we just saw in the Xi book is you can have a fill character. And so that would be an example. Let's shift over to Replit and look at examples. Replit. Okay, so suppose we have a string. Let's have a floating point number. And how about an integer? Okay, so let's do some playing around with formatting. So print and dot format and S. So this is going to be the string. The braces are the template where the string is going to be filled into. Now, if we do nothing, that will work. Python main.py. So that's simply printed the string. I'm going to add outside the braces double quotes. Double quotes, right? So let's see that. So notice that only as many characters as was necessary have been printed in between the double quotes. But if we making sure we're recording, then add the colon and let's say 10. Let's try that. So now notice that there are some trailing spaces on the right-hand side. I'm going to put in a less than here, and that's not going to change the output because the less than says left justified, and it was already left justified. I'm going to change that to right justified. And now the blank spaces appear before the string. And we just saw in the book about fill characters. So I'm going to put in a plus sign there. And any leading or trailing spaces are filled in by the plus sign. Do you have questions so far? Okay. Let's try the integer. And heck, I'll just put in the integer there. And right justified, all the blanks are filled in with plus signs. The plus signs are specified here. All right, let's try a slightly more interesting floating point number. I'm really screwing myself up here. All right, let's do the float. Now let's see if each of these works. Okay. 4, 5, 6, 7, 8, 9. Let's see what happens now. All right, now on this line 7, I'm going to introduce the decimal place and say that I only want to see 3 numbers after the decimal place. Oh, I guess that's a total of 3 numbers. Yes, sorry. That should have been, I'm confused. I thought it was going to be 3 numbers after the decimal place. Okay, looks like the professor needs to brush up on his iBooks reading himself. All right, so these are the basics. Do you have questions?
Do you do like 0.3F or something for decimals or 0.3D? I think it might be one of those too.
Maybe that's why it didn't work out. Ah, there you go. Thank you. Extra credit. So by adding the F, that specified, okay, this is a floating point. I want 3 numbers after the decimal place. Thank you. All right. We also have learned about we've learned about positional templates. Let's try that. So I'm going to go here. No, I'll make a new one. Print 0 colon and 1 colon S and I. Let's see what that prints out. Okay, so the positional case is there's a number that's coming before the colon. So that says take argument 0 and print it here, and argument 1 and print it there. Now, if you'll note, S and I, S precedes I, so I can change the order that they're being printed out as by changing the numerals. Now I'm getting I first, even though it's listed second as in the list of parameters, list of arguments. And finally, there's one more way, which is used less, used quite a bit less. So here's foo colon, and then I'll say that foo equals. Okay, so here I'm specifying which parameter to print by giving it a name and assigning that name a value. Now, I do want to emphasize that print itself is not part of string formatting. Let's do that by saying FMT is equal to, well, I'll just take this whole thing. Okay, and now print FMT. Okay, so on line 9, instead of directly going to print, I wanted to emphasize that the return value of string formatting is a string, and that could be assigned to another variable. Okay, so how did I do? Does this give you the review you wanted?
Yeah, that was pretty helpful. Thank you.
Okay, good, good. I'm glad to help. Other review questions? How about questions from the book?
I had one about else if statements. Is there like a specific case where it would be bad to just use a second if statement? And so like if it was trying to think of the example from the book that I had. It was like if x is -1, then do this, and then the next one was else if x is 0, do this. Could you just do a second if statement, or does it have to be else if?
Well, it depends. The deciding factor is, do you want mutual exclusion or not? So for instance, let's see, you had if x is equal to what, 0? -1?
I think it was -1 in the book. Yeah.
The word pass, by the way, is says, I didn't write this code yet, so just pass over. And then it had else if.
Yeah, it was like
Okay.
else if x equals 0 or something like that exactly.
Okay, so in this case, it would be identical to have done it this way. Okay, this would be identical because they are mutually exclusive based upon their own values. If something is -1, it can't be 0. If it's something is 0, it can't be -1. Also, you could do it this way because there's only the two cases. But suppose you had a lot of cases like this and 2, 20, 10, and 30. These also are all mutually exclusive, but there's a lot of cases. So you might want to consider two things. Consider putting in elif. And the reason for that is you know that only one of these is going to be true. So when you hit it, let's say it's -2. So when you get to the -2, you hit the -2, it's not going to test this one or this one or this one. So there's a speed advantage by putting in elif instead of just ifs. And the other thing to think about is, what was I thinking when I said there were two things? Oh, yes. So if you have something like this, which is not that unusual, you'll want to think about put these in the order of the most likely first so that you hit it quicker. Okay? So let's say 95% of the time, the answer is going to be -10. So that means the way I wrote it here, 95% of the time, I'm going to have to do line 20, line 22, line 24. What did I say? 20? Whatever it is that I said, 95% of the time it's going to be -10. So you'll have to do all those four to finally get here. So if it's true that you know in advance which one is the most likely to occur, then put it first. And that way, your code will be higher performance. There is an art, there is some thinking, around what order to do if statements in. Now, if they're all ifs, right, then these multiple ifs have the potential to be executed, and they are not all of them, and they are not mutually exclusive. So let's say x is greater than 20, and x greater than 30. Now, if I put in a number of 100, both of these are going to execute. If your intent was that it was supposed to be mutually exclusive, then you'd use the elifs. Okay? All right, does that help?
Yeah, that makes sense now.
Good, good. Okay, another review question or a question from the book?
So I had a question about floats, and when you define a float, does it ever round down to like the 10th place, or does it just stay to whatever decimal place you've defined before?
Well, that's an interesting question. So let's say you have a float that's 1.23456. 7. Okay. So if we print that, what do we get? We get all those decimal places. But let's say you only wanted to see 2 decimal places. Well, you could do that with string formatting, like we saw. So dot format. But I think your question is going beyond this. But let's do this first. So here is, I want to see 2 decimal places, and you call it a float. And let's go. Unmatched. Thank you. Okay, so there's 2 decimal places. Now it's 1.23 because if you look at the next digit, it's less than 5. So if that next digit had been more than 5, I wonder what would print. See, so the string formatting is going to do rounding. Was that where your question was going?
Yeah, I think it helps me, but also when you're comparing integers to floats, the integer is going to be converted into a float, right?
Correct.
Okay, so for this one question, it was like 4 plus 1 exclamation point equals 5.0. So in that case, would that be true or false?
Could you tell me where to find it in the book?
It's it's 4.4.
Okay. And whereabouts?
It's a participation activity. It's 4.4.7. It's the first question.
Or
4.4.7.
I'm working on it. There
Okay,
it is.
there you go.
Okay.
It's the first one.
So click the expression that is false. All right. Well, 5 is less than or equal to 5. And 10 is not equal to 9.99999. And 4 plus 1 is not equal to 5. So which one of these is false?
It's the third one.
This one?
Yeah. So then
Oh,
is,
five not equal to 5. Yes, that's false. Right.
yeah. Okay.
Yeah.
Right.
Where my head was at is it turns out, uh, depending upon the values, this could be true. But this is what we were studying today in computer organization. It's a more advanced majors only required course. And it turns out that computers can't exactly represent all floating point numbers.
Hmm.
Many of the numbers, in fact, most of the numbers are just approximations. And I'd like to show you an example, but I don't want to get too far down the rabbit hole. Let's see. New share. Okay, so you can see this, and let me make it bigger by making it smaller. Okay, so let's see. Now I gotta remember where I put it. No. Oh, it's just right there. Okay. All right, so let's take a number like 2. And this is the internal representation of a 2.0. And you're able to represent it exactly. So 2.0 is 1 times 2 to the first power, and it's 2. Okay, good. How about a floating point number like 1.2? Oh, how about by 0.5? It turns out 0.5 you can represent exactly. And the reason you can is that 0.5 is a power of 2, right? Its power, a 0.5 is 2 to the negative 1. So you're able to represent it exactly. But let's say something like, oh, I don't know, 0.1. So a computer can't actually represent 0.1. Instead, it comes up with an approximation. So that's the internal value of 0.1. So the general rule is any floating point number whose value is exactly a power of 2, including negative powers of 2, can be represented exactly, and all the others are approximations. Okay, but that's interesting. It's way it's above and beyond this course. Actually, that's not true. So let me give you a for instance. Whenever you're doing comparisons with floating point numbers, you have to be careful. And the reason for that is you might be saying, let's say you have a floating point number. Oops, wrong. Back. Okay. So you should, for critical work, avoid doing exact comparisons against floats. So suppose you have 0.1 assigned to F, right? Now, if you were to, this is not going to make perfect sense, but the right way to test against a specific value is to use an absolute value and a difference. So you should do something like this. If the absolute value of F Now I got puppies nipping at my feet. So if the absolute value f minus let's say 0.1 is less than a very small number called epsilon. This is how you would do careful comparisons in floating point. So let's look up, let's go to REPL. And I guess I've gone down a rabbit hole here, but I'll surface soon. So import math, and we'll just do it here. So import math, and there's going to be an epsilon in math. Let's see. All right. No, that E is E. ERF. I'll have to get back to you on this to find epsilon. See, never go off script. Epsilon in Python. It's actually a little bit more complicated. So it's part of CSC. So let me just bring that back into Replit. Where did I put Replit? Maybe it's here. Yeah. So I'll just finish this. Okay. So it's import sys. Okay, so remember I mentioned that the floating point values, many of them are approximations. Well, this number epsilon is a very small number, and it is the smallest value that the computer can distinguish between. So any errors in math calculations should be less than or equal to this number. So if you look at how I framed this comparison, I'm looking for differences which are less than epsilon. And if the difference is less than epsilon, then it's equal. I've confused everybody. When you get to a point in your programming career of doing really fine calculations, differences of huge numbers, things that are of critical importance like life or death, and you're needing to compare to floating point values, you have to do it carefully. Remember that something being absolutely equal to something else is not necessarily true, even though they're really, really, really close together. Okay. Sorry about that. I went down a rabbit hole. I acknowledge that. But my rabbit hole did not, in my own defense, it did not include a pizza parlor and satanic rituals. Okay. Don't look at me. I don't have any cookies for you. Go look at someone else. Okay, questions from the book. Let's take a look at what you have coming up that's due. Project 3 is due on Monday, so you still have some time on it. Chapter 4 is due tonight. Also, no, she scratched me. Get away, go. You're done. Out. Okay. So you have a midterm on the 23rd. It'll be in class. It'll be multiple choice administered through the computer on Schoology, in fact. On the 18th, we'll have a review day. Now, here's how I work review days. On the review day, you have to ask me the questions. I can't predict what it is that you'll need review on. So if on Tuesday, no one asks a question, we have a 0-minute class. We just fold up our tents and go home. Right? So before Tuesday, the 18th, I'm sorry, before Thursday, the 18th, you should be thinking about, what do I need to ask about? What do I feel vulnerable about? What do I feel not confident about? Make sure you ask those questions. Okay? Okay. So recently we've been learning about how to read text from a file. So I'd like to return to that first by answering a question that you may have, and that is, how do you handle an error in opening a file, for example? And I said we would learn that. So let's take a look. I've got a file here called shelly.txt. And what we've seen so far is if I want to open and read from that, I can say input file, and that's just a variable name. You could use other names if you want, equals open and shelly.txt. And then I'll say print the file is open, and then I'll close it.
I'm still seeing the iPad.
So you are. Okay. All right. So I have a file called shelly.txt. Let's run this program. So Python main.py. Py. Okay, so the file is open, the file is closed. So that's review. However, if we have, let's say we can't open the file. I have no file, shelly.txt. That file is not here. Let's try this again. That's a crash. And Andy Warhol, the famous artist from the last century, said something to the effect of, dying is one of the least private things imaginable, because then somebody has to go through your stuff, right? Well, dying should be graceful in your coding. You don't ever want to show somebody this stuff here. This is unexpected and fatal. So if there are errors, you want to handle them gracefully. And I promised you that I would show you how to do that. So here we go. All right, there's a Python keyword called try. And that introduces a block of code. So it's a colon. And then code. Now, if the block of code generates an error, you can catch that error. I'm going to look here and see it says file not found error. You see that on the right-hand side? File not found error. So I'm going to copy that, put it here. And here I'll handle it gracefully. Okay. Let's run that. Okay. So no crash, because you handled the error. Anybody have any questions about that? Now, if the file did successfully open, whoops. File is open, file is closed. Okay, so the goal is never to crash. Crashing is impolite. All right, now another thing relating to files is you can certainly use this technique to open and close files. There's another syntax that I'd like to show you. I'm going to comment out that line and write in this alternative. With open of Shelly.txt as input file : and now we don't need that. And we don't need that. But we do need another block indentation. So with open as a variable name introduces a block of Python statements. And when that block of Python statements is complete, the file is automatically closed. So when you get here, even though there's no input file.close, it's still closed. When you've left this block of Python statements, the file is automatically closed. So this is a gentle introduction to something called exceptions. Exceptions come from attempting with try and intercepting errors with except. Okay. Any questions about this? All right, then I'm going to put a link in the chat. And I'd like you to download the file that I'm going to link to. I'm almost there. Okay. So everybody look at the chat. There's a link there. I'd like you to click it and then add that file to Replit. So I've done that already. So after downloading the file by clicking on that link, you'd use the vertical 3 dots to upload it to Replit. Okay, so here's what that file looks like. And it's make-believe student records. So the first column, and these are all separated by commas. First column is the student ID of the make-believe person, the last name, a first name, the gender, unfortunately binary, then a make-believe email address, what academic level you are, junior, senior, freshman, sophomore, how many credits you've completed, what your GPA is, and what your major is. Okay? The majors, by the way, are all real Carthage majors. So we have a major called MUT, which I'm guessing is like music theory, teaching, maybe MUTT. Michael, I'm wrong?
No, it'd be MED.
Well, like I said, we have a major called MUT. I don't know what it is. So this, notice that all of these values are separated by commas. Have you ever heard before of CSV? CSV data, CSV files.
Aren't those supposed to be like charts?
Are they like what?
Charts or tables?
Yeah. So CSV files are the most common data file format. And you can think of this, what you see here, as a table. That's true. Line 1 has multiple columns. Every line has multiple columns. Line 1 has all of the data for one person, Sarah McDonald, made up name. So this is like a chart, like a table. Now, as this is the most common way of transferring data between applications, data between people, it's really important that we learn how to read a file, interpreting it as CSV. Okay? Now, let's do a comparison. Let's see if we try to read from it, what will we get? And I don't remember, here it is. Okay. For a line in input file, print the line. Now this one, when you run this, you're going to have to kill it using Control-C because there are 3,000 lines. That is, oh, that's the wrong file. stu data.csv. Okay. That was 3,000 lines. But when we read a line, the data is not broken out. In order to make use of this data, you would have to separate out the values in between the commas. Fortunately, Python has a way to make that easy. So follow me here. Import CSV. And now let's filter the raw data through the CSV package. So reader is equal to csv.reader, and that is going to take as its input the file. Okay. So once again, so I'm opening a file regularly, the normal way, and I know that it's a CSV file and I want to parse it as a CSV file. So I've imported CSV, which stands for comma separated values. So I open the file and then filter it through, I'm sorry, that should be reader. Yep, filter it through csv.reader. And now let's take a look at what the output is this time. Okay, take a look. Instead of raw text, you're getting a Python list for each line where the list members were the individual columns of the CSV data. How are we doing? Any questions?
Mine is for some reason not doing it.
Okay, do you have studata.csv?
Yes.
Okay. I will make it possible for you to share if you're willing to share. Go ahead, if you're willing.
Okay.
Okie dokie.
Yeah. And let me, there you go.
Thank you. Can you, line 1, what you've forgotten is the import CSV.
Oh, okay. How do I stop? Right here. Yeah. Okay.
Okay.
Thank you.
All right. But you're welcome. But also there's a couple other changes you need to make. And I'll go back to mine. See, here's the wrapping of the CSV package around the file, and
Mhm.
then reading it as if it were CSV. Okay, so now that we can open and parse a CSV file, we can start collecting data out of data files. For example, let's say academic level, and we'll make that a dictionary. So what I want you to do is add the code to count the number of freshmen, sophomores, juniors, and seniors. Then print. Okay. So let's take a look at the data file and figure out how to get at just the academic level. So follow me. This is going to be, if you notice, you're getting back lists here. So this is lists of 0, 1, 2, 3, 4, 5. So the column we want is column 5. Okay, so column 5 is the academic level. So just as a experiment, let's take a look. What is row 5, column 5? And let's see if we got that right. And as you can see, there's I have to just disable Siri on all the machines that I have. So Siri just gave me a giant set of recommendations on what I can do with column 5. Well, let me tell you, Siri, what you can do with column 5. Take that in your pipe and smoke it. All right. So column 5 will get us to the academic level. And now, like project 3, how can you count each of those? Have you worked on project 3? We've done part of it in class, kind of. So you might want to say that you just want to do this, academic level, row, column 5, plus equals 1. So that's probably your first idea. But we've covered this, and we know that this is not going to work. Let's try it. So that's another one of those kinds of errors. This one's a key error. And you're getting a key error because in order to add 1 to the number of juniors, we first have to find the previous value of the number of juniors. Yet it's an error because right now, first time through, there are no juniors, so the key fails. So you need that if statement. that we did in a previous class. So if row 5 is in academic level, actually I want to reverse that, not in, then let's initialize it. Academic level, row 5 gets the value, initial value of 0, and then we can add 1 to it. Yeah, I'll leave that there for a minute. Okay, so drink this in. Make sure you're understanding it. Ask questions if you're not.
So what does what you wrote mean?
Okay, so I can put some comments in, sure. So reader is now a CSV filtered view of input file. Okay, then each line in the file is read and parsed as CSV formatted data, one line at a time is put in row. Academic level is a dictionary where the academic level is the key and the number of lines found with that level is the value. Okay? So column 5 is the academic level. So that is the keys. Good so far?
So is this just how many things are in row 5 or column 5?
Column 5 will have 4 keys if the data is prepared correctly. But each of those 4 keys will have a number associated. Let's run this. So there were 732 juniors, 773 seniors, 753 freshmen, and 742 sophomores. Okay? So, for example, the very first time we find junior. So this says, line 21 says, if junior is not in the dictionary, which it isn't because it's the first time you're seeing a junior, then initialize the dictionary's value for the key junior with a 0. Then line 23 is the dictionary's that has key of junior has 1 added to its value. So does that clear it up?
Yes, now I think I understand. Thank you.
Okay, good. All right. Let me leave this here for a little bit. Ask questions if there's something that is not clear to you, please. Okay, so I'm going to remove these comments so that I can fit more code on screen. All right. How about only among, what if I wanted to know how many juniors and seniors and freshmen and sophomores were in each major? Okay, so now we're starting to get into more sophisticated modeling here, right? Cool. So let me do that again. Let me state that again here. Okay, so how many junior, senior, freshman, and sophomore are in each major? So this query has multiple levels to it. You figure out which one is the top level. By parsing this sentence. Okay. So would it be natural to have a dictionary which at the top level was, junior, senior, freshman, and sophomore? So that's the top layer of the answer we want. And then for each of these, we've got the different majors. Right? And then one more level for each of these would be a count. So how many computer science juniors do we have? You go to the top level dictionary, look at JR. There's a dictionary inside the dictionary. Woo, that's cool. There's a dictionary that has a key of CSC, and that maps to a value, which is the number of juniors who are computer science majors. Okay, so there's a dictionary at the top which maps level to another dictionary. That dictionary maps major to count. Ask me a question. I dare you. I double dog dare you. Which can only, of course, be countered with I triple dog dare you. Okay? All right. Nobody has a question. Everybody gets this. Okay. Then let's begin assembling our data structure. So we can say, all right. breakdown by major is at the top level a dictionary, right? Then if it's okay with you, I'm going to eliminate the previous code. So I'll say if your major, I'm sorry, if your academic level is not in breakdown by major, then let's put it in there. But this time, instead of a 0, it's going to be another dictionary. Okay. So now we can say, so I've identified a junior. Now I get to look among juniors, are there any computer science majors yet? So if this is going to get very long, I'm going to change this, sorry, BD for breakdown. If BD row 5, and you know what, that's getting kind of hard to understand. So I'm going to say that your major is, no, that was your academic level. Academic level is equal to row 5. So now I could make this a little shorter. Oops, I lost the character. So breakdown indexed by your academic level. And which one is your major? Let's bring that back up again. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So column 8 has your major. All right. And to make it easier to remember, I'll say academic level is equal to 5 and major is equal to 8. So instead of row and 5, which is the magic number, I'll replace that with academic level. So if your major not in there, now we can put that in. So breakdown for junior, seniors, et cetera, that's the academic level. And for your major is equal to 0. BDAL major plus equals 1. So now we're accumulating a count. So here we're saying make sure academic level is in the top dictionary. Right? If not, create the dictionary for the second level, and then make sure major in the second level. And then finally, increment major within academic level. All right, so instead of printing academic level, that's gone. Let's find out how many juniors who are computer science majors? There are 16. So this is, BD is a dictionary of junior, senior, freshman, sophomore. And then within each of those, there's a breakdown by major. You got it? Let's take a look at that code. Now, just stay on this until you have a question or you've gotten it. Okay, whose head hurts? Okay. Can you articulate a question? I'm going to take my chances on another drink. Hope I don't spill it on the keyboard again. So the goal here is to be able to come up with models that represent the data you're interested in. And the data I'm interested in is for each academic level, for each major, how many are there? And that's why I started where I started. So this, I'll repeat that. So for each academic level, for each major, how many? So that's a dictionary. That's a dictionary. And this is a count. So the top level maps academic levels to dictionaries. Then the second level maps major to count. And that's why finally you see a syntax like this. Okay. So here's the top level dictionary. And this is the key for the top level dictionary. And this is the key for the second level dictionary that yields a count. Okay, anybody have questions?
So it counts them all twice?
It counts what?
does it count them all twice or read through the whole thing twice then?
Well, it's one pass through the file, one pass through the file. And the counting is broken down first by academic level, then by major. Okay, so allow me to print them out separately. Okay, so here's print.
We still see
whole
the
thing.
iPad, by the way.
Thank you. So here's the whole thing, and that's going to be really, really long. Let's see, did I? All right, so save. Okay, now this is really, really long. Let's see if we can make any sense of it. Okay, so here's a key. Here, well, first of all, it says dictionary. That's the opening brace. And the key is junior. Now within junior, you've got PYC, and there are 14 of them. I don't know what PYC is, but here's math. I know what math is. So within junior, there are 9 math majors. Looks like I got some bad characters in my data. I'll have to go figure out why that got there. So you see that? Don't see that. Ignore that. So the junior lasts from here until here. Then the next entry is senior. And that lasts from there until, let me see if I can spot it, until here. There. Those are all, that's the breakdown of just seniors. Then comes freshman, and then finally will be junior. So I've got a bad major somewhere in my, so the ACC major has some corrupt characters in it. I'll figure that out. Okay, does that help? Did that help? So it's pretty incredible how expressive you could be with just dictionaries, sets, and lists. So what I've done essentially is built a database inside computer memory. I've built a database that will very quickly allow me to answer questions relating to how many of a particular major are there at the senior level, at the junior level, at the freshman level. And you know what? This actually allows me to do much more, but I think that I've already overloaded you with enough new knowledge. And look at how few lines of Python it took. Okay, so I'm going to stop here because I think I have overloaded you, but that's okay. This is your first time. So one last time, I'll ask for questions.
I feel like I have the same thing that you have, but whenever I run it, it always comes out to just being 1.
Okay. It's that sounds like we might not be running the right thing. Is it okay if you share your screen?
Yeah, I should be able to do that. Wait. Oh, that's not right.
Okay.
Hold on, let me unsure that. Why is it?
Yeah, no, I think that's right.
Oh, it's just not showing me the right thing. Okay,
Okay.
there we go.
Okay, so try running your program.
So, yeah, I just let me click.
I see why. Oh, yeah, you just, no, wait, I don't see. Let's see, so what's being printed? Oh,
Well, I changed it to
so
SO because JR wasn't working, but
JR wasn't working, but we should be using the same data. So run that. Okay, I wonder, just humor me here.
Mhm.
Click on the left-hand side to open up your list of files, and click on import.py, the vertical dots on that line to go down to import.py, the vertical dots.
wait. Oh yeah,
Nope, not
wait.
those.
This one?
Okay, yes, those.
Oh, sorry, I was looking at the one above.
And rename the file to a different name.
Just name it name.
Okay. All right. Now try that. Okay, it was worth trying.
Yeah.
All right. So now I have to
It's-
actually look at
It's
your
the
code.
final if statement. The plus equals 1. That should be to the left one. It shouldn't be within that if statement.
Ah, yes. What was just said is true. Line 21.
Okay. Wait, what about it?
Extent line 21 by 1 level.
Okay, like
Extent. All right, so eliminate one space. Is that okay? Tell you what. Good. Now hit tab. Tab key.
no. I can barely hear you. I don't know why.
Oh, I don't know why. Can anybody else hear me?
I can hear you.
I can hear you.
Yeah.
Ice
Okay.
flare bolts.
Yeah, I can hear you
the
pretty
ice
well,
flare
too.
bolts
No,
are
the one that was saying what the solution was, I couldn't hear.
The on line 21 needs to be even with the if statement on that same level. So you need to, yeah, there you
So
go.
that okay.
Yep.
Yeah. Try that.
Oh, perfect. Thank you.
Okay. So what was happening is the increment by 1 was happening only the very first time. So it went from 0 to 1 back to back, and it stayed there. Okay. All right. So we're starting to get into an exciting part of the course, because the more tools we have for modeling data, the more sophisticated we're going to be able to problems we're going to be able to solve. Okay. Does anybody have any questions? Last time.
Yeah, I actually had one on the program too. I'm trying to run it, but I keep getting a syntax error on the print
no, because I
line.
took away his.
I don't really know
wait, what?
why.
On program 2, project 2.
No, for just this in-class one
No,
that
I
I
didn't
just did.
swap anything.
Oh, okay. Would you be willing to show your screen?
Yeah, I would be.
I just removed the one that literally isn't active at all, and it reset everything.
Okay.
So what power level are you? 'Cause
That, can you see it?
Yeah, yep, we do
Okay.
see it.
I
Let's
don't
see.
type
Well, first it says
This is
line
like-
22, so let's draw our attention to line 22. There is no line 22. Okay.
Yeah.
fucking
BB.
what?
Junior. And so print.
Or what if it just
So
what if
what's
it-
going wrong must be,
it's a true
yes, I see it.
every time you shoot it?
The remainder of your try except seems
you
to be
using it right now?
missing.
Oh, yeah. Okay, that's what it is. I didn't put it because I
Yeah,
didn't
you
think
just
I needed
don't
it, but I obviously do.
Yeah, well, you need it because you have the try.
Hmm.
Okay.
So new line,
Wait,
good, and accept file not found
I'm
error,
gonna use my grenade.
space, capital letters. Yeah, there it is.
Mhm.
Colon,
I mean, so far, I'd say I like this season.
and how about just saying
It's
exit?
interesting. Doesn't
Just hit exit
story is
Yeah.
anything, but like
like that.
Okay.
crazy
Yep.
yet. But I haven't
Try
gotten
that
into
now.
it.
Alright.
I haven't gotten into it yet.
All right, now I'm getting.
Well, like, no, I'm not saying that. I didn't say that.
Okay.
Wait,
You
Arthur, is there
got an
a
answer.
wait? Was there a
Okay.
a
All right.
transport up
Sounds
there?
good.
Okay.
All right, we'll
I'm
stop
So
already
sharing.
going. I heard. I went to
Any-
Vegas, so I'm just used to it.
anybody else? Okay, if you have questions, follow up with me or with our tutor, Bailey Wellen, bwellen@carthage.edu. I can meet with you, she can meet with you, and I'll see you on Thursday.
Thank you.
Yep. Thank you.
Thank
See you,
you.
Professor.
Have a good one.
Bye-bye, you too.